Hello everyone, welcome back to Calculus 2. In this video, we are going to talk about the chapter 3.1 integration by part. So let me go down slowly. So far we've been talking about how to take the integral, and especially we have many different, different types of function. And then especially when you have composition function, we've been utilizing a substitution method. And if you have a trigonometric function, or depending on the function, there's a different technique. There's a different integral technique we've been utilizing. So in chapter 3.1, what we are going to do, what if your function, so let's say your f of x, what if you are multiplying two functions, and how to take the integral in that case, right? So if you remember, in calculus 1, when you have two functions and then it's a multiplication, and when you're taking the derivative, you remember this product rule. So you take the derivative, the first function, and then you are going to take the second derivative of the second function, and then adding them up, we call this is the product rule. So maybe we could do the similar thing when you're taking the integral. What if I have, so now I'm gonna make a little bit smaller. I'm trying to take the integral when you have two different functions. How would you be able to take the integral? So that's a question mark. That's the main idea in chapter 3.1, and I will show you how to take the integral in this case. Maybe we're going to utilize this product rule. So here we go. I'm going to show you a little bit of proof stuff. So we have a story. I want to take the integral when you have two functions and it's a multiplication. So according to the product rule, right, fx times gx, I can just rewrite the product rule. So f prime x gx plus and g prime x times f of x. And then we are taking the integral. So it looks like a little bit complicated because I'm trying to use some, the similar idea, what we did in differentiation, but we are trying to take the integral, right? So what we're gonna do, I'm gonna do the distributive property. I'm gonna separate them. So the integral f of x times g of x is equal to integral f prime x gx dx plus, I'm just using the distributive property, so separate them. And then maybe this is same with above equation. And here, what I'm going to do, let's say this is going to be square. Let's say this is going to be the triangle. Let's say this is the star. So in this relationship, we can see square equal to triangle plus a star, correct? I'm going to change this order a little bit, solving for star. So star is going to be square minus triangle. So I'm going to just change the order. Let's say star is equal to square minus triangle. So let me rewrite down the order. So the integral g prime, this one is the same as square minus triangle, correct? I'm just changing the order, nothing is special yet. And then here, I'm going to change the order a little bit because this derivative is a little bit bugging me. So I'm going to change that order. So integral f of x first, g prime dx equal to, there's no prime, so f of x, g of x dx, and I'm going to change that order again. So gx first, f of prime dx. And then what I'm going to do, we have a two function f and g, and this equation looks a little bit complicated. So I'm going to convert. Let u equal to f of x, and let's say v equal to g of x. So we have a g prime with the dx. This is going to be v prime because, so the u prime is f prime. You're going to take the derivative, and then v prime, that is actually same as a g prime and dx. So therefore, as you see that, this g prime dx, it is going to be v prime, correct? And then f prime dx, this is the same as u prime, correct? And then this is going to be just u, and then this is going to be uv, and this is going to be v, correct? So by utilizing u and v, we can rewrite down this equation. Integral uv prime, that is equal to uv minus v integral v u prime. So we call that we're going to utilize this relationship to take the integral when you have the product of two functions. We call this is integral by part theorem, IBP. And then when we're going to use it, we're going to use this IBP when or for the integral of a product of two functions. So that's what we're going to use in 3.1 entire units. So one more time, you don't need to memorize this proof stuff. I'm just trying to convince you where and how this formula came from. We call this is integration by part formula, especially when you are dealing with the integral of the product of two functions, especially like when you're multiplying two functions and taking the integral. This, taking the separated and using the product, that looks really complicated. So what we found out, you're going to just use this formula as long as you can find out the u, v, u prime, v prime. IBP method going to help you to find out the integral of a product of the two functions. Does it make sense? So we're going to utilize this IBP method as one of the integral technique, especially when you see the product of two functions. We call this is IBP. So I'm going to highlight it a little bit. So in calculus, integration by part, or we call partial integration, is a process that finds the integral of a product of the function in terms of the integral of a product of their derivative and antiderivative. Simply, you're going to use this IBP when you are taking the integral of a product of two functions, okay? So just keep in mind, there are many different integral techniques that we introduce. You have to know when and how to use it. So there are different type of function you're dealing with. Depending on the function, you might be using substitution method or trigonometric techniques or IBP method techniques as well. So you don't need to memorize this proof stuff. Let's just, keep in mind when and how to use the IBP. When you see the two functions, multiplication, think about the IBP method. So I will show you the example, and then you might have a better understanding. Let's take a look at the following example. Here we go. So example 1. So I want you guys to take the integral x times sine x dx. So this is literally we're taking the integral, but here we go. Do I see any sub-function? I don't see any sub-function. This is just two function, x and sine x. And then if you go to integral table, there's no specific techniques we can find out the outcomes. This is just, we don't know what it is. It's not going to be used by substitution method because I don't see any subfunction. Therefore, we have to think about another relationship, another perspective. What's going on x and sine x? Oh, they're multiplying it. So this is definitely a product, right? They're multiplying a product between x and sine x. Therefore, I see the product of two functions. We're going to use IBP method. It says that we just proved that u dv equal to uv minus v du. This is the formula we just found out. So IBP method says that you're going to find out what the u function, what the v function, what the du, in other words, u prime, or dv, v prime, you're going to find out those 4 components and then plugging in, and then you can find out the answer. So therefore, let's look at the function one more time. We have x and sine x. So what I'm going to do, I'm going to say the u, that's my two, one of the function. I'm going to x equal to u, that's my f function. And then as you see that in this structure, this is together sine x and dx. This is a dv. Oh, this is a dv, which is your v prime. So they said dv, which means this is the v prime, or g prime x. It's a given sine x dx. Are you following? I'm just defining what the given is. U is x, and then dv is, so this is x, dv is a sine x dx, right? So we're going to find out the rest of information, what the u prime, what the v. So IBP method always asks you to find out the rest of information. So I'm going to make a little bit smaller. So what are you going to do? Make a 2 table. Okay. So we know f of x equal to x, which means this is the u equal to x, correct? You're going to take the derivative. Take the derivative to find out what the u prime. So you're going to take the derivative u equation in terms of the x. So it is going to be 1. So it means that du equal to dx. So you said, u prime is going to be 1, right? So this is going to be u prime. So we can rewrite here. I'm going to make a little bit smaller. So from here, by taking the derivative, we found out u equal to x and u prime equal to 1. Are you following? So this is something we discovered from the first table. You need u and u prime anyway. And second table, what do we know? We already know v prime, correct? So we already know v prime equal to sine x dx. So I want to find out what the v. So to get the information of v from the v prime, if you take the integral, right, you will get what the v was. So one more time, v prime, we already took derivative. So v prime equal to sine x dx. So if you take the integral sine x dx, you will get what the v was. So therefore, if you take the integral of the sine function, it is going to be negative cosine x. So we got b equal to negative cosine x. b prime was given sine x. So you have all the information b and v prime. Are you following? So one more time, this is a very important concept, the integration by part. We don't have any skill to take this, to take the integral of this particular function. You have a 2 function f and g. This is f and g. And then we're going to utilize the IBP method. So according to that method, you're going to define what the u is x, and then v is, this is a v prime is a given. So that's a sine x dx. We have u and v prime information, but we don't have a u prime and v information. Therefore, by taking derivative of the u function, you can find out the u prime. By taking integral of the v function, because we already know v prime, by taking the integral antiderivative, you can find out what the v was. So by taking both the derivative of the first function and taking integral of the second function, you can find out these 4 important information, u prime, v, and v prime. That's it. Once you got that information, we're going to finalize it. So this means that is equal to, so fu in integral u du, they say uv minus integral v du. Correct? So therefore u, we already know, x. V, we have negative cosine x minus integral v, we have negative cosine x. And then du, that's actually your u prime. So remember du, this is the same as a u prime. So you have a 1 dx, right? So du equal to dx. So 1 times the dx. So we have everything. So one more time, u is x, b equal to negative cosine x, b equal to negative cosine x, du is a dx. So once you've set it up, it's going to be negative cosine x, double negative change to positive, integral cosine x dx. So negative cosine, oh, I forgot the x here. So x, negative x cosine x, negative x cosine x. And then if you take the integral cosine x, that's going to be sine x and plus a c. That's your answer. So we just applied IBP method to find out the answer when you take the integral of a product between 2 functions. And then what is the IBP method? You're going to find out 4 important components. In the question, always u and dv. In other words, u and v prime is a given. All you need to do, you're going to find out u prime and v. Those are 2 other information. So by taking both the derivative of the first function and taking the integral of the second function, you can find out all these 4 information. As long as as long as you have those 4 components, then plugging in and you can finalize the answer. That's the IBP method. Okay. So I hope this is not makes you crazy. It's gonna be fine because we're gonna keep practicing for the rest of time. So let's keep going. Okay, let's keep going. I'm trying to show you guys all the step-by-step work as much as I can. Let's take a look at the bottom example. We're going to keep utilizing IBP because I will show you 2 functions of multiplication in terms of the integral. So let's take a look at the second example. So remember IBP one more time. You have u dv that is equal to uv, right, minus v du. So you need to find out u prime, v and v prime, then you can plugging in into everywhere. So you can finalize the answer. So let's do letter A. Ooh, so integral ln x dx. So if you go to integral table, it's not really easy what the integral ln x. So we have to think about a little bit, deeper. So what if I have invisible 1 here? So now you have a product. So now this is a product between ln x and 1. So you have 2 functions and you see their multiplication. So I'm going to say the ln x is going to be my u. So I'm going to say let f of x, that's going to be my u. Let's say this is ln x, correct? And I'm going to say 1 times the dx, that's my second function, but that's actually already derivative. So that's a dv, so that's a g prime, which is a v prime, that is already 1. times dx. Okay, so we good. We have all the information, but I need to find out what the u prime and what the v was. We need to find out that. So I'm gonna take two things. One is taking the derivative, differentiation, and then you're gonna take the integral of each function. So the u, we know that f of x equal to ln x. That means u equal to ln x. To find out the u prime, you're gonna take the derivative, du dx, ln x will be 1 over x. Go to table, so take the derivative of the ln x is gonna be 1 over x. That means cross multiplication, du times x equal to dx. That means du equal to dx over x, correct? So from there, we found out u and u prime. What is that? U equal to ln x. And then we found out u prime, which is 1 over x. Here's a 1 over x dx. That's your u prime, 1 over x. So we found out those information. U is ln x. Taking the derivative of the ln x, it is 1 over x. So we got it. Now let's go to the second function b. So we have g prime, which is b prime. So that means dv over dx, it's already given 1, correct? So to find out the v information, you what? Don't forget that, take the integral 1 dx. So therefore, v equal to x. Are you following? So you're gonna take the integral of the second function, right? And then you can find out what the v was, because this is a v prime. By taking antiderivative, which means integral, you can find out the original function. So now we have v equal to x, v prime equal to, oh my bad, yeah, v equal to x and v prime was 1. So we have every information. So therefore, what happened? I'm gonna make a space. So from there, we can find out integral ln x dx equal to uv minus integral b du according to IBP. So you know what the u, ln x, we know what the v, x, minus integral v is x, du. What is a du? You have a du right there, 1 over x dx. So 1 over x dx, correct? So one more time, u, v, du. So therefore, this is going to be x times ln x minus, oh, they're gonna be canceled. It's gonna be 1 dx. And then x times ln x, taking the integral, it's going back to x plus c. That's your final answer. So we got the answer, x times ln x minus x plus c. By utilizing IBP, you found all the u prime, v, and v prime. That's a key point. So this is IBP method. Does it better? How you feel? I hope this is getting better and better, right? So you can always pause the video and you can try yourself. And the key point is creating the box table. Take the derivative of the first function to find out the u prime. Take the integral of the second function to find out the v. So that once you have u prime, v, and v prime, you can plug in into all the IBP method and you can finalize the answer. So that's how you are taking the integral, this complicated function. Okay, we got this. Okay. All right, so let's take a look at the second example. I'm going to change the color. So this is the second question. I'm going to bring all the way down. So here, let's say B. The question was x times ln x dx. Okay, I see you. What's going on? So you might be confused a little bit. Which one should be the first and second function? So if you remember, just one tip, if you have ln, always the log function should be the first function. If you have an exponential function, that's going to be the first function. So a little bit of note, log or exponential, they have a priority to become the first function. Okay, just remember. So we have a what? This is a product between x and ln x, and then we're gonna utilize IBP. What is? It's going to be u dv equal to uv minus v du. We're gonna utilize this IBP method. So to apply IBP method, you need to find out all the u prime, v, and v prime. So we're gonna say, let the first function, your u, I'm gonna say ln x because they have a priority. So it's going to be ln x. And then your second function, it's actually g prime already. So it's going to be x times dx together. That's a g prime, which is a v prime is x times a dx. So by creating the table, we can find out all the information. Take the differentiation of the first function, take the integral of the second function. So u is a given, ln x, let's find out the u prime. So du over dx, again, it is a 1 over x. So we know du times x equal to dx according to the cross multiplication. So du will be dx over x. So therefore, we have a u equal to ln x. We have a u prime is what? 1 over x. So we have u and u prime. Are we okay? Because this is u prime. And now we're going to take the integral of the second function. So v prime is already, we know, x dx. So taking the integral, you can find out the v function. So taking the integral, v will be x 1 plus 1 divided by 2. So v equal to x to the second over 2. So we have v equal to x to the second over 2. V prime is x dx. So we have all the information. So now once you have, what we're going to do, I'm going to minimize a little bit. Minimize it. So we have this. So what happened? We have a question x times ln x dx equal to uv minus integral v du. So plugging in u equal to ln x, v equal to x to the second over 2, correct? Minus integral v x second over 2 du is right there. We have a 1 over x dx, correct? So therefore, if I simplify, it is going to be ln x, x second over 2, integral, I can bring 1 over 2 to the front, and x cancel, 1x remaining. 1x remaining. So we can get it. I'm going to minimize it a little bit. Just 1 second. So let me minimize a little bit here. I'm going to bring all the way up here. So from there, I can try ln x times x second over 2, 1 over 2, and take the x, 1 plus 1 divided by 2 plus c. Okay, finally, ln x, x second over 2, 4, 2 times 2 is a 1 over 4, so x to the second over 4 plus c. Yes, this is your final answer. So we got the final answer right there. Taking the IBP method, you found out u prime, v and v prime, and plugging into your IBP, and we got the final answer right there. Does it make sense to you? I hope it's getting better and better. So I'm gonna hold up here for a second. So we're gonna keep practicing it, keep going slowly and surely. Okay, we're gonna take a look at the next question. You never know what kind of function you're gonna deal with. So I'm showing you all the possible, cases. So let's go to C. I'm gonna change the color. What is the C right there? So I'm gonna bring all the way down, C. So let me rewrite the question here. The question was take the integral ln x over x to the third dx. Dun, 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 dun. So it's a very interesting format, looks like a fraction, but you can modify it. It means integral ln x times 1 over x to the third dx. And then I don't like the fraction. You can simplify with the negative exponent ln x times x to the negative 3 dx. So now you see what? This is a product of two functions, right? So we're gonna utilize what? IBP method. So according to the IBP, this one, so I'm gonna write it, the integral ln x times x to the negative 3 dx will be equal to, so this is integral, what was it? This is the integral v, u and dv. This is u dv equal to uv minus integral v du. So we need to find out all the information uv and v prime and v. So let's take a look at it. So I'm going to get rid of it for a second. So which one is the first function you want to see? Okay, we have two functions. So I told you ln or exponential, they have priority to be the first function. Don't you remember? So I'm going to say the ln is going to be my first function. So let's say let u equal to ln x, right? And then you're going to find out, what the, u prime, and then also I have a v prime. It's already given. This is your b prime. So x to the negative third dx. So create a table. Take the differentiation of the first function, take the integral of the second function. So u equal to ln x, take the derivative, it's a 1 over x. So we know du times x is a dx. In other words, du equal to dx over x. So we found that what? U is ln x, u prime is a 1 over x. So we have this information, and du equal to dx over 1 over x. Good. Take the integral. So v prime is a given, x to the negative 3 dx. You're going to take the integral to find out the v. So therefore, this is going to be x to the negative 3 plus 1 divided by that summation exponent. It is going to be x to the negative 2 over negative 2. So just a little bit of note, x to the negative 1 is 1 over x. X to the negative 2, everybody know, x to the second. So I can flip this. So 1 over negative 2, x to the second. So we have v equal to negative 1 over 2x to the second. V prime was x to the negative 3 dx. Oh, we have every 4 important information. So therefore, we can finalize it. So we have a question, ln x times x to the negative 3 dx. Now, it is uv minus v du. U ln x times v, 1 over negative 2x to the second. Take the integral v, 1 over negative 2x to the second, du. Do you have a du right there? So 1 over x dx. So we have all the information. Now simplify. So I can bring the negative to the front, negative ln x, 1 over 2x second. And then I can multiply, right? Negative 2. We have a double negative. You can change to positive. So now 1 over 2 positive 2x to the third dx. I can bring the 1 over 2 to the front. So negative 1 over this is the same. And then bring 1 over 2, 1 over x to the third dx. Again, I can convert x to the third as, x to the negative 3. So let me double check if I have any mistakes. So I think we are good. Yeah. Okay. Oh, we have du was, let me double check. Du was a 1 over x dx. We good. Okay, therefore, we have a negative ln x, 1 over 2x second. This means x to the negative third dx. So now we can finalize it. 1 over 2, x to the negative 3 plus 2 and minus 2 plus c. I need a little bit of space. So negative ln x, 1 over 2x second. 2 times 2, negative 4. So we have 1 over negative 4. X to the negative 2 plus c. You can change x to the negative 2, convert it to the positive exponent. So let me just double check here. Minus ln x. Oh, I need a space a little bit. So almost 1 over 2x second minus 1 over 4, 1 over x to the second plus c. So you can say negative ln x, 1 over 2x second power and minus 1 over 4x to the second plus c. That's your final answer. You can simplify. All right, are you okay with that? I'm gonna hold up here. All right, so we got this. Okay, so check it out. I'm just keep showing you the same strategy over and over and again. So you need to check if there is a product of two functions for the integral, find out the IBP method. You're gonna find out u prime, v and v prime, and then plugging into the IBP and finalize that answer. That's how you're gonna do it. Because our textbook, integral table does not show you what that is exactly. We have to solve it. Okay, so far so good. So I'm gonna do just 2 more examples according to the IBP. Are you ready, ready? So let's go to the next one. Here we go. Okay, so we have a similar question. I see the 2 multiplication. We have a 2 function, and then you have to determine which one is going to be the first function. So this is definitely we're going to utilize the IBP method. You're going to find out the u, v, u prime, u, v prime, b, du. We're going to use the IBP. So you might be, hesitate which one is going to be the first function. Both of them exponential. X to the second, e to the x. So if you have both exponential function, x is going to be the base. So this is like a e to the x, very complicated function. Always x, whatever the base to the x, right? So if you have both of them an exponential, but this one has a priority when you have x in the base. So we're going to say, let u equal to x to the second, correct? You're going to take the differentiation, correct? And then you're going to take the integral for the second function. So u is going to be x to the second. Therefore, du over dx is going to be 2x. That means du equal to 2x times dx. So we have all the information. U equal to x to the second. And then you have a u prime equal to 2x. So highlighted, u equal to x a second, u prime 2x, and du is a 2x times a dx. Good. Second function, we have a g prime, so v prime all together, ex times the dx, e to the x dx. So taking integral, you can find out the v. So e to the x dx. V will be same e to the x, because e to the x is always the same. So we got it, v equal to e to the x, v prime is e to the x dx. So we have a v prime. So let's plugging into the IBP method right there. So this one, u is what? X to the second. V is e to the x minus taking the integral. V is what? E to the x du, we have a 2x dx, correct? And then, whoa. I'm gonna simplify x to the second, e to the x, bring number 2 to the front, so e to the x dx. Wait. Highlighted. You see that? I have a little bit of typo. I forgot the x dx, right? Because the 2 just bring to the front. What I'm saying is, when you look at this part, let me write it, e to the x. When you look at this part, what happened? Again, 2 functions product. So you are going to use second IBP method, because there's a 2 function. There is another product of 2 functions. We already finished the first IBP, but there's a second one. So we're gonna utilize the same thing, e to the x times x, okay? So always x has a priority in the base. This is x to the 1. So you're gonna utilize the second IBP, taking the differentiation, taking the integral. So in this time, u will be x, so u prime will be 1, right? In other words, this is a du over dx. 1, du will be dx. So we have u equal to x, u prime is 1. Second function, what is it? E to the x times the dx. So therefore, v prime is already e to the x dx. And then by taking the integral, you can find out the v. So which is e to dx. So we have v here, and we have a v prime here. U and u prime and du. So according to the second IBP, we're gonna continue. I'm gonna just make a little bit of space. So here we have, I'm gonna plugging in here this one, another uv, v du, u x, v is e to the x minus integral, v e to the x du was a dx. So therefore, x e to the x, if you're taking the integral, there's no more product, just e to the x. But wait. Yeah, we got it. We got the e to the x, correct? So we finished the second IBP. I'm gonna plugging in this one into here. So let me go back to the green. So we had original question, x second, e to the x dx, said, we stop here, x second, e to the second minus 2 integral, e to the second times x dx. What we just found out, this is here. So I'm gonna plugging in x second, e to the x minus 2, x times e to the x minus e to the x. Good. So now you have all the answer. I'm gonna simplify. E to the x, distributive property, 2x e to the x, plus negative, 2 e to the x, nothing, we can combine it, and then plus a c, that's your final answer. So in this question, you had two, IBP method to find out the finalized answer. So keep in mind, sometimes you might need to do second and third IBP method, depending on the question. All right, we got this. How you feel? Getting better? Okay, so in this video, we're gonna keep practicing it so that you're gonna build up a better confidence. That's my hope. So, this video is, trying to show you all the work. Let's move on to the second question here. The letter B, let it be. So I'm gonna bring all the way down. I'm gonna minimize it, this part. All right, second question. So I'm gonna change the color. I'm gonna make a space. So the B right there. So if I write down the question, taking the integral, again, you have a product of two function, e to the 3x. So I definitely see the two function, and then x base of x has the priority. So that's gonna be my u. So let's take just take the, differentiation and integral. I'm going to bring this one here. Okay, so we know u equal to x to the second. So du over dx, 2x. So du will be 2x times dx. So therefore, what we got? U is x to the second. U prime is 2x. So you have all the information. Oopsie. Change the color. U is x second, u prime 2x. And then du is 2x times dx by taking derivative. By taking integral, so we already know e to the 3x dx, this is already v prime. So v prime e to the 3x dx. By taking integral of that v prime, you can go back to v. So what is it? Many people forgot. I'm going to make a big note. So if you remember, integral e to the x, it's always e to dx. But integral e to the nx constant, go back to the table, you're going to have e to the nx, keep it, and divided by the constant. Do you remember that? So based on this idea, it is going to be e to the 3x divided by 3. So that's your v. So we have everything. V is e to the 3x over 3. V prime is e to the 3x dx. Okay, let's go to IBP. So u, v, integral v du. I'm going to bring here. So therefore, you can u is x to the second. V is e to the 3x over 3 minus taking the integral v e to the 3x over 3 du is a 2x dx. So I'm going to simplify. So this is going to be 1 over 3x to the second e to the 3x. I'm going to bring 1 over, actually 2 over 3. That's better. 2 and 3 is a constant. So 2 over 3 integral e to the 3x and x dx. Dun, 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 dun. One more time. Second IBP. This is second IBP. Second IBP. I see two, a product of two functions. So we're going to take it one more time. So we have x to the 1. This is the priority. So we're going to take a second IBP. Integral. So u equal to x. Du over dx is 1. Du is a dx. So we know u is x. U prime is 1. Taking the integral of the second function, so which is e to the 3x and dx, that's already v prime. E to the 3x dx. So by taking integral, we can find out the v equal to e to the 3x over 3. So we have u prime, v v prime. So we're going to take a look at the second IVP. So uv minus integral v du. U was what? X times v, e to the 3x over 3, taking the integral v, e to the 3x over 3, and du was dx. So it is going to be 1 over 3x e to the 3x, bring 1 over 3 e to the 3x dx. Keep going. That means 1 over 3x e to the 3x. And then this part, e to the 3x divided by 3 plus c. But we don't need to write down plus c right now. I'm going to simplify. Let me just minimize a little bit. So you can finalize. That is 1 over 3x e to the 3x, 3, 1 over 9 e to the 3x. That's your second IVP. We're going to bring it back into there. So I'm going to bring back all the first IVP. So let me change the color. The first IVP, so 1 over 3x to the second, e to the 3x minus 2 over 3. Now you're going to plugging in. This is second IVP right there because we just calculated. 1 over 3 x e to the x minus 1 over 9 e to the 3x. Are you following? So this is what the second IVP outcome. Second IVP. This is a second IVP. This is a second IVP. So we plug in back. Then we're going to expand it, correct? So 1 over 3, x is second, e to the 3x. All the distributive property, 2 over 9, x e to the x. Negative, negative, positive, 2 over 27, e to the 3x. Nothing, we can combine it. So that's actually your final answer, plus a c at the end. Whoa, we made it. Okay. That's how you are doing the, taking the IVP, especially when you look at the product of two functions. Does it make sense to you? Okay, so we've been practicing a lot. So this video is going to be a little bit longer because I want to practice more. So we're going to take a look at a couple more example like this. Couple more example, okay? I'm going to show you the following question. So let me go down slowly, okay? Okay, so let's take a look at the bottom. A little bit challenging question. The example 4, okay? So we are looking at sine ln x. Whoa. So it's a very interesting structure when you look at it. Usually sine x, and then what happened is ln x has been subbed into the sine x function. Do you see that? And then if you want to use IVP, you need a two function. So this is a one function. Let's say there's an invisible one. Okay, so now you see the structure. Sine ln x, this is a one function, and there's a second function 1. This is a product of two functions. Especially with the first function, I see the sub function. So nothing is special. We're gonna just keep, taking the IVP method. So according to the IVP, so let me just minimize this. According to the IVP method, we're gonna take the differentiation and integral. So the differentiation, the first function, I say u equal to sine ln x, correct? And you are going to take the derivative. So du over dx. So remember, many people maybe forgot d over dx sine x, that is a cosine x. And then if you have sub function like nx constant, it's a 1 over n cosine x. So therefore, what are you guys gonna do? Oh, actually, you're gonna keep the same nx here. Nx, cosine nx. And therefore, what happened? We have d over dx sine ln x. So you're gonna take, this is a chain rule. First of all, this is gonna be cosine ln x. And then you are going to take the chain rule 1 over x. Chain rule, which means take the derivative of the ln x. So this is going to be, we are using chain rule. So d over dx ln x is 1 over x. So that's why they're going to be here. So this is the, what's your derivative of the sine ln x. So therefore, this is going to be cosine ln x and 1 over x because of the chain rule. So du will be cosine ln x, 1 over x, and dx. Are you okay? So we took the derivative. Yeah. So that's very important. We took the chain rule. So now we're gonna take the integral. We're gonna take the integral of the second function, which is a v prime is 1 times the dx. So v prime 1 times the dx. To find out the v, take the integral. So v is going to be x. So we have all the information. U prime, v, and v prime, correct? So you're gonna plugging in IBP method. I'm gonna just minimize a little bit. So according to the IBP, sine ln x times 1 dx equal to uv minus integral v du. Are you guys okay? So if I do, u is what? Sine ln x minus, and then v was x minus integral. V is x, du is a cosine ln x, 1 over x, dx. So I'm gonna simplify sine, I'm gonna bring x to the front. So x times sine ln x, x cancel, so integral cosine ln x dx. Bum, 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 bum. Do you see another what? Dun, 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 dun. Second IBP. Okay, there we go. There's a second IBP. So this is second IBP. Because there's invisible one, you have two functions multiplication. So same thing, let u cosine ln x. So by taking the derivative, cosine is going to be negative sine ln x, and you're going to take the chain rule 1 over x of the subfunction. So that means du will be negative sine ln x 1 over x dx. And then by taking the integral, we already know what? 1 times the dx, that's a v prime. So v prime, 1 times the dx. So v will be, by taking the integral, we got v equal to x. So you're gonna plug in back. So let me just minimize a little bit. I know always we need a more space. So here, so according to the IBP, uv minus integral v du. So u is cosine ln x, v is x. V is x, du, we have negative sine ln x, 1 over x, dx. Again, x I can bring to the front, ln x. I can cancel, double negative change to positive, x cancel. So we have only sine ln x dx. Wait, Professor Ben, are we really going to use a third IBP for this part? No, because it's a keep repeating something going on. So now what I'm gonna do, we need to see the structure one more time. So what was our question? Our question was, I'm gonna rewrite it, integral sine ln x dx. And then I stop here before we're gonna take the second IBP. That was x times sine ln x, correct? And then we found out the second IBP outcome is right there, correct? So I'm gonna plugging in, subtract the second IBP, x times, we have a cosine ln x plus integral sine ln x dx. Are you following? So that was the second IBP I plugging into to the original step. So now in this equation, I see something commonality where this sine ln x dx, sine ln x dx, they are the same thing. So what we're gonna do, let me expand it one more time. So I'm gonna rewrite it, sine ln x dx, x times sine ln x. Let's expand the negative to everywhere. Distributive property. So cosine ln x, negative, positive, negative, sine ln x dx. Because we want to know what does sine ln x taking the integral. So now, since they are same, can I move this one to the other side, like an equation? So I'm adding sine ln x dx on both of sides. So now sine ln x dx, I'm moving this one the other side. So positive sine ln x dx, that is equal to x times sine ln x minus x times cosine ln x, correct? So this means the same thing to 2 integral sine ln x dx. And then this is the same here. I'm going to copy, paste. So now we are solving what the integral sine ln dx. So now you're going to do divided by 2 on both of sides. So if you do that work, simply integral sine ln x, our question, it is going to be x times sine ln x minus x times cosine ln x over 2. That's your final answer. There's no more integral. That's your finalized answer. Because we are just looking for what the integral sine ln x dx. So that's your final answer. So sometimes if you observe there, keep finding IBP method, maybe you can stop at some point. There's a commonality you can combine, and then you can find out the answer in a shortcut. Okay, that's what it is. All right, I hope it's getting better and better. So I'm pretty sure you can watch this video multiple times because it's not easy concept, but the more you practice, the better you feel. Okay, so practice is a necessary. So keep utilizing our lecture note and video so that you're gonna gain your confidence. That's the important part. Okay, take a look at the next question. I'm gonna bring that question. So let me minimize a little bit. All right, so I'm gonna bring this question all the way down. So let's take a look at B. So B said, we have a 5x cosine 3x dx. Obviously, I see two functions going on, 5x times cosine 3x, and then cosine 3x has a sub, 3x has been sub. So you remember x has a priority, so I'm gonna say, let u equal to 5x. So we're gonna take the derivative. Du over dx will be 5. So du is a 5, dx, we take the differentiation. So we know u is a 5x, u prime is a 5, and du is a 5 times dx. And second function is right there. V prime is cosine 3x dx. So by taking integral, you can find out the v. And then it is going to be cosine will be sine 3x. And you have to take the chain rule. 3x will be, you're going to use a chain rule. Remember, you're going to have a constant. I'm going to write one more time for you. Integral cosine nx dx is going to be sine nx, and you're going to divide it by n, right? And then if you have sine nx dx taking the integral, negative cosine nx and 1 over n. So this is the note you can find out from the table. So there's a 1 over 3. So this is going to be v. So there's a chain rule. So we have all the information. So therefore, integral 5x cosine 3x dx. We're going to take the u times b du. So u was 5x, v is sine 3x times 1 over 3. Integral sine 3x 1 over 3 du is 5 times dx. So simply simplify 5 over 3 x times sine 3x. And then I can bring the constant 5 over 3 sine 3x dx. So 5 over 3 x times sine 3x. And then you can take the integral. This is going to be negative cosine 3x times the chain rule 1 over 3. So the final 5 over 3x sine 3x. And then 3 you can simplify double, negative change to positive. 5 over 9 cosine 3x plus c. That's your final answer. Okay, that's letter B. I hope it's getting better and better. So we practice a lot. How you feel so far? While you're watching this video, I hope you stretch a little bit, right? But again, I'm literally using the same strategy, IBP. Taking the derivative of the first function, take the integral of the second function, so that you can keep finding all the 4 important components, then utilizing the IBP method. So that's your final answer. Are you guys okay? So keep watching this video. I'm going to do the last concept here right now. Okay, so if you feel you're ready to see the next concept, we are still in 3.1. So now what do you think? What we are expecting? What if we have a specific definite, right? So far we didn't have any interval. So that's the next one. If we have the specific definite integral, yes, your answer is going to be much simpler. So let's take a look at it. So I'm going to keep using the IBP. And then, the formula looks ugly, but we know how to, take the IBP method. IBP, you're going to have u dv equal to uv and v du. So now we have a specific interval. So capital B minus capital A, that's something you're going to do at the end after you finish this integral. So here is the example. I have a specific interval 0 to 1. And then in this time, we have a tangent inverse. So to utilize the IBP, let's assume there's an invisible 1. So we have 2 functions, tangent inverse times 1. So we can utilize the IBP method. So let u equal to tangent inverse. And then if you take the du over dx, so go to table, the integral table, just you remember, d over dx tangent inverse x. If you go to the integral table, it's going to be 1 over 1 plus x second. It's a given. So the derivative of the tangent inverse, it's going to be 1 over 1 plus x second. So that means du equal to 1 over 1 plus x second dx. So we got u and u prime, right? So this is a u prime. We have a u by taking the derivative. Let's continue. Take the integral of the second function, which is a 1. So v prime is already given 1 times the dx. And then by taking the integral, you can find out the v, which means the antiderivative. So b will be x. So we have all the information from the table. So now this is uv from 0 to 1 minus same thing, v du, but you have a specific the interval from 0 to 1. So don't worry, we're going to get there. So u was what? U was a tangent inverse, and times v, we got x. So we're going to take a look at 0 to 1 minus integral 0 to 1. V is x, and du is 1 over 1 plus x second dx. Are you okay? So let's a step-by-step work. I'm going to minimize it a little bit. So this part, capital letter at 1 minus f0. So it is going to be tangent inverse 1 minus tangent inverse 0. So you can calculate this. Oh, actually, I forgot the x. So let me rewrite it. Tangent inverse. So I forgot the x. Tangent inverse x times. So let me rewrite it. This is a tangent. U is a tangent inverse x. And v was x. So we have 2x. So tangent inverse is 1 times 1 minus tangent inverse 0 times 0. So this is the first term. That is going to be anyway 0. You're going to multiply 0. So this is tangent inverse 1. It means arc tangent 1. So the first term gives you the answer arc tangent 1. So let's talk about the second part. We can modify 1 over 1 plus x second, same as 1 plus x to the second to the negative 1 exponent, because I don't like the fraction. So now you can think about the u substitution, because you can use IVP, but that's going to be long work, but still you can use either substitution method. So what I'm going to do, you're going to find out x times the dx in terms of the u. So let's write it here. U will be 1 plus x to the second, right? And then take the derivative, 2x. Du will be 2x times the dx. This is substitution method right there. So then we have 1 over, we need to find out x times the dx. So if you divide it by 2, both of sides. So I'm going to write it du dx. If you divide it by 2, both of sides, we have exactly 1 over 2 du equal to x times the dx. That's what we got. X times the dx is 1 over 2 du. So we can now rewrite all the information. So let me make a space. So finally, we have arc tangent 1 minus integral 0, 1, 1 over u, right? Because that's your u, 1 plus x squared. And then x times the dx is 1 over 2 du. We got it. So therefore, arc tangent 1, 1 over 2, 0 to 1, 1 over u du. Yes? And then you remember taking the integral 1 over u, we talked about it, it's going to be ln u, correct? So it's going to be arc tangent 1, 1 over 2, ln u from 0 to 1. Gotcha. So now almost done. 1 over 2 ln 1 minus ln 0 because we have a range. So arc tangent 1 minus 1 over 2. This guy will be 0, right? By the way, I think we have a little bit of missing piece. Do you remember? Since we are using the substitution method, we have to change 0 to 1 in terms of the u interval. So here, 1 second. 0 to 1, we have to convert to the u variable. There we go. So u 0, 1 plus 0 square 1. So 0 gonna be 1. And then 1 will be 1 plus 1 square 2. So actually it's 1 to 2. So we have to change that 1 second. So we have, instead of 0 to 1, everything should be 1 to 2. So that's my bad. So we have 1 to 2, 1 to 2, 1 to 2. So 2, 1. Better. So therefore, that is going to be 0. So we have ln 2. So you can finalize the answer. Arc tangent 1, if you go to decimal, type it. It's a pi over 4. And then you can bring 1 over 2 to the exponent because it's a log. 2 to the 1 over 2. That means pi over 4 minus ln radical 2. That's a super final answer. Wow, wow, wow. We got this. So this is a little bit, you know, mixed question. Not only you are using the IBP method, but also substitution method so that you can finalize the answer in a better way. So especially here, we also have a specific definite integral so that you have to subtract the large minus 0 as well. That's what you need to do. Getting better. So we can do this. Okay, so I'm going to hold up here before I'm going to show you the last question for today. So I'm not really worrying about the definite because you guys know what to do. The only thing is if you don't know the IBP, then it's going to be trouble. But now we've been practicing, you know, a lot of IBP method problem. And then although you have a definite integral, it's the same strategy. After you got IBP and simplify, right? Simplify from large to minus a small area so you can get the answer. Yes. So I'm going to go to a couple more examples, just one more example. Here we go. So keep practicing. We have a definite integral right there. So we have a two relationship, right? So it's an IBP. So definitely you're going to utilize the IBP method. So u dv ub minus v du. So that's IBP. So we have u t times e to the negative t. So this is your base, t to the 1. So this one has a priority. So they actually need to change dt. So I'm going to change a little bit, same variable. So instead of x, we have a t. So x times e to the negative x, same thing. So let u equal to t. So du over dt is 1. So du will be dt. So we have all the information by taking the derivative. B prime is already e to the negative t dt. So by taking integral, you can find out the v. So it's going to be you're gonna keep the e to the negative t and then divided by negative 1. That's what you need to remember from here. E to the nt dt, you keep and divided by n. So that's what I did. So we have all the information. By taking derivative, by taking integral, we got it. So now uv minus v du. Your u is going to be t. V is going to be negative e to the negative t. So this is the same as negative e to the negative t. And then minus integral negative e negative t. Du is a dt right there. Du is a dt. Let me just rewrite it. So therefore, t times minus front e to the negative t, double negative change it to positive. And then we have negative t. So I forgot something. We have here is 0 to 7, 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 right? So let me calculate that. So you're gonna get what? Negative 7 e to the negative 7 minus, wait, 0 is everything will be 0, isn't it? So that's a 0. Plus, if you take the integral, this is e to the negative t divided by negative 1 from 0 to 7. So keep going. So this is negative 7 e to the negative 7 plus, this is the same as a negative e to the negative 7 minus e to the negative 0. So I'm plugging in 7 and 0. All right, so we got this negative 7 e to the negative 7, and then minus e to the negative 7, e to the 0, this is going to be 1. And then double positive, so that's your final answer. We can combining this two. So negative 8 e to the negative 7 plus 1. Beautiful, that's your final answer. So we got this question. Okay, so you can do it. It's not really complicated at all. Okay, so I'm not going to do the rest of question because I've been showing you how to take the IBP method in terms of, when you're dealing with the product of two functions. You can try the following two examples, but I will show you the concept. This is a definite integral, so we know what to do. And then I see the two multiplication. So log has a priority. So you say u equal to ln t. So du over dt is a 1 over t, correct? So du equal to du times t will be dt. In other words, du is a dt over t. So you can find out u and u prime. And then b prime here, radical t times dt. So you can take the integral to find out the v. And then this is the t to the 1 over 2. So you're going to take the integral, t 1 over 2 plus 1 divided by 3 over 2. That's a v. In other words, you can flip this one, 2 over 3, t to the 3 over 2 is a v. Excuse me. So you have all the information, then take the uv from 1 to 4, take the integral 1 to 4, v du, try the next one. So you can try this. I'm not going to finish. I trust you guys can finish this question. Same strategy. And then one thing, if I help you, the last two questions, same thing. This is a little bit of application problem, but it's, think about it, sketch the region bounded above by the curve. So x-axis, x equal to 1, and find the area of the region. So you have a function, and then the function is given, y equal to 2x times e to the negative x. They're looking for the area up to 1. So this area. So we know, taking the area, we're going to find out the area by taking integral from 0 to 1, 2x times e to the negative x. Again, you have a two function, and then x base has the priority. So you're going to say let u equal to 2x. du is a 2. So du over dx is a 2. So du equal to 2 times the dx. And you have, there is a dx, right? Because we are looking for the integral of the product of two functions. So therefore, this is the v prime, e to the negative x dx. Taking the integral, you can find out the v. So v will be e to the negative x over negative 1, which is negative e to the negative x. So you have all the information. Again, this question is asking you to do the IBP. uv from 0 to 1, minus b du. You're gonna plugging in and you can finalize the answer. So I'm gonna leave it this question for you. You can finish up. That's all about 3.1. Woohoo! We finished 3.1. Can we celebrate for a second? Yes. So we just introduced chapter 3. I'm gonna show you all the techniques. There are so many integral techniques in calculus too. That's the main idea. Depending on the question, what kind of techniques you're gonna utilize it. That's each units are introducing. So, you can, watch this video whenever you're ready, and then you can solve all the quizzes whenever you're ready. So finish all the 3.1. And then if you have any question, engage in discussion chapter 3. So that's where you're asking question and getting help. And feel free to email me if you have any question. I will see you in the next video very soon. Thank you, everyone. Bye-bye.